Hello everyone, and highly welcome to my presentation, which is one amongst series of our Cloud Academic Webcast in the year of our Lord 2021. My name is Armstrong Angwili, a cloud-based engineer at Amanox Solutions in Bern, Switzerland, and with great passion I would love to pull your attention as of how Aviatrix multi-cloud network architecture must have revolutionized the shortcomings that we encounter within a native cloud service provider, I would say network construct, not architecture. And by the end of my presentation, the verdict is yours. The content of my presentation will be built within the following topics. I will talk about the drivers behind the case study, the challenges that we're going to encounter, solutions, result, and as well as the conclusion. The drivers behind my case study would be Company A Data Center 1 connect to AWS Region 1 via a Sunrise link with 1.25 gig. For high availability purposes, the same construct is being repeated, this time around from Data Center 2 via Swisscom link of 1.25 gig to Availability Zone 1. Due to multiple customer acquisition and an increase in workload both in the cloud and on-premises, with new governance and compliance regulations, this has propelled both the IT and management board to long for a multi-cloud network architecture solution, with a north-south throughput enhanced from 1.25 gig to 25 gig, and within the cloud, from east to west, at least 50 gig. But as we all know, the native networking construct of each and every cloud service provider that we have in the market today comes with limitation. That's to say, it's rudimentary, non-intelligent, and it doesn't support network or advanced networking. For instance, AWS provides or provision you with the network security group, your router and the routing table, VPCs and VPC pairing. But when it comes to troubleshooting, you can only access the routing table of this native router, but you can't access the router itself. So it becomes troublesome if you have to granularly go through some certain troubleshooting circumstances. When we want to talk about security, the network security group also, though advanced enough in such a way that it can still accept third-party security vendors such as Palo Alto, Checkpoint, and Fortinet firewalls. But it also comes with limitation in terms of throughput. You are limited to 1.25 gig, though the appliance may excel beyond that. And if you have to encrypt, then you are only left with at most 500 meg. There are other hurdles in terms of segmentation that you have to maybe deal with full meshing before you can achieve your goal. So if you have just a single VPC, 2 or 3 or 4, it's fine. But if you have above maybe 50 VPC based on your recommendation, doing a full mesh is a call for concern. So if we are being restricted and limited within a single cloud, talk less us scaling out to Azure, to Google Cloud, and as well as Oracle Cloud, we should understand that each and every cloud service provider has its own shortcoming. The language are different, the terminology, and the concept. So what are the challenges that we have to overcome to make sure that we achieve our goal? First, we make sure that the manageability at scale is secured. We make sure that end-to-end encryption and high performance that we are limited within a native cloud construct be overcome. Mandated segmentation by allowing the possibility for us to segment within and without, using all the multi-cloud capacity, not only in the single cloud, let's say AWS, but still having a uniform segmentation across each and every cloud vendor that you've chosen to have. Service insertion, you are now having the capacity to use active-active instead of active-passive, and the high performance throughput beyond 1.25 gig. Visibility and troubleshooting in terms of accessing not only the routing table, but you are able to access the router itself using Copilot, for instance. The challenges that we have to overcome within the native cloud service provider transit network construct would be how we're going to manage our entire multi-cloud architecture at scale. End-to-end encryption and high performance. How could we exceed the limitation of just 1.25 gig to our desired throughput of 50 gig? Mandated segmentation. How are we going to be able to make sure that we can segment within the same cloud service provider and as well beyond a single cloud service provider with uniform and consistent performance? Service insertion. How could we as well insert third parties, next generation firewall, appliances, and exhaust the entire capacity of active-active, not only limited to active-passive, and beyond the 1.25 gig throughput within east-west traffic in the cloud? Visibility and troubleshooting. How could we be able not only to be limited of accessing the routing table of the router, but as well be able to access the router itself? So the solution would be, as I've earlier stressed on, Aviatrix, a third-party broker. With the previously mentioned challenges, we can't talk about the solution without the component that makes up that solution. Aviatrix Enterprise Cloud Transit Multi-Cloud Network Architecture is made up of at least 3 main components, which are Aviatrix Controller, Copilot, Transit and Spoke Gateways. Built within a 3-tier construct known as Cloud Operation, Cloud Core, and Cloud Access, and with utmost security within all tiers that you can see at the right-hand side of the diagram. Remark: since Terraform is an official provider of Aviatrix, it's considered an associate. What does Aviatrix perform? Aviatrix does maintain the underlay construct of each cloud service provider and thereby build an overlay topology that has the capacity to interact with every and any cloud service provider via built-in APIs. Based on our case study, Company A began with a single cloud AWS Region 1 and with the capability of multi-account provisioning, high availability, active-active instead of active-passive, an end-to-end encryption with maximum throughput east-west in the cloud to up to 90 gig, and if encrypted, 75 gig, which has already met our requirement. And with network correctness by finding overlapping CIDRs with recommendation to do intelligent NATing between on-premise and in the cloud. And as time goes on, they can thereby replicate this same construct or architecture to Region 2. So you see into it that due to multiple customer acquisition as earlier stressed, that propels Company A to long for multi-cloud network architecture, customer will quickly move to multi-region using the same hub and spoke architecture. And here we see already the repeatability, which makes the task much easier. When the customer is ready to go to multi-cloud, that same architecture then repeats itself on the Azure, Google Cloud, and as well Oracle Cloud infrastructure. When it comes to high performance and encryptions, with Aviatrix Insane Mode, you are capable of leveraging up to 25 gig IPsec north-south traffic, and via express route and inside the cloud up to 90 gig. That's to say, if you have a failure between the private link data center 1 and data center 2, you still have the same capacity of throughput in the cloud of up to 90 gig. Multi-cloud network segmentation, which scale out through the entire multi-cloud construct, e.g., you may have the green, which could be considered for dev, the blue for production, and the violet for service workload. So you have the possibility in multi-cloud environment to segment your entire infrastructure. When we talk about service insertion and chaining, Aviatrix as an agnostic software uses its FireNet feature to provide service insertion and chaining, and this is where we can bring in next generation firewall from other vendors of your choice, such as Palo Alto, Fortinet, Checkpoint, etc. And even as well as your SD-WAN connection could be as well incorporated. Enterprise operational visibility. That's where Copilot give you the provision of a real enterprise class troubleshooting visibility. As we all know, what you don't see, you can't control. So here is where we provide the same visibility as though you were on an on-premise network environment by using Copilot. Secure cloud access for remote network and mobile users. These avoid data backhauling from on-premise to the cloud. You can as well directly access the cloud using Prisma Access if need be. Secure ingress and egress, where instances in the cloud may likely want to connect directly to the third parties via the internet as well through the next generation firewall. And finally, based on certain demand, you still have the possibility to connect to your native cloud resources. And this gives you the capacity and the probability to scale out, to expand your network based on your recommendation with no or without limitation for further growth. Remark, I know one would certainly ask, should in case the controller went down, what else? Please never mind. Terraform will retrieve the configuration file of the controller that was stored in the S3 bucket and rebuild the system within minutes or seconds without interrupting the data plane of the entire network, because the control plane is totally separated from the data plane. The results that we are going to envisage. I hope my tips, or I hope you enjoy my tips. Make sure you visit our channel, subscribe, like it, and if need be, do not forget to contact me at armstrong.anguili@amanox.ch. Thanks and stay blessed.